Dear friends, hello. Today we will discuss about mapping an ER model to relational model. In previous lectures, we have learnt about ER model and relational model. So, today we will start our discussion with the need of mapping an ER model to the relational model. As we know that an ER model is a conceptual model, it gives a good overview of entity relationship which is easy to understand. But an ER diagram only gives conceptual representation which cannot be implemented into a database directly. So, in order to implement it directly into a database, we need to map it into a relational model. The basic idea of mapping an ER model into relational model is to build a relation for each entity set of ER model, so that each entity set can be defined individually. In some cases, it becomes necessary to build relation on each relationship set, then we must build it. For every attribute of the entity set, an attribute in the relation must be made. Relationships will be mapped as foreign key. The identifier of the entity becomes key of the relation. Now, let us look at the mapping from ER model to relational model. For mapping an ER model to relational model, a 7-step model is followed. These steps include mapping of regular entity sets to mapping of n-ray relationship types. These steps are discussed one by one as. First is mapping of regular entity types. Each regular or strong entity type E in the ER schema is implemented as a relation capital R that includes all the simple attributes of capital E as its attributes. In case of composite attributes, break its component in simple component attributes and add them as simple attributes. Any key attribute or set of attributes of ER diagram E may be used as candidate key for capital R. If the chosen key attribute of capital E is composite, the set of those simple attributes that form key of E will together form the primary key of capital R. Consider the ER diagram shown with student as entity type with name, class, roll number and subject as its attributes, and here roll number is the key attribute. Then it will be mapped to relational model as shown. Here entity type student has been converted into relation with this name, and its attributes become the attributes of this relation. Roll number was the key attribute, so this roll number also becomes the primary key in this relation. The relation student corresponding to this will be as shown. Here key attribute roll number of ER diagram is taken as the primary key of the relation student. Consider if we take name attribute as composite attribute in ER diagram with its component attributes as F name and L name, and resulting relation student will contain attributes F name and L name in place of the name attributes in the relational model. The relation will look like as shown. Second one is mapping of weak entity types. In case of weak entity type W with strong entity type E, in ER schema build a relation R with all the attributes of W as attributes of relation R, whether the attributes are simple or composite. And in case of composite attributes, break them in simple component attributes and add them to the relation R. Add primary key or keys of strong entity type E as foreign key to R. By doing so, the relationship between weak entity type W and strong entity type R is maintained in the relation capital R. The primary key of R will now consist of the foreign key and the partial key attribute of weak entity type W if there is any. So, consider the ER diagram as shown, in which two entities, student and dependent, are shown. The student entity type has attributes roll number and name, we mean student name here, and the dependent entity has attribute name, and here we mean dependent name. The student entity type is a strong entity with roll number as its primary key, whereas the dependent entity type is a weak entity type. Both the entity types are related to each other with depends relationship. So, during its mapping into relation, dependent entity will consist of attributes name and roll number, where roll number is the key attribute of student entity type and becomes the foreign key for the relation dependent. Also, the primary key of the relation dependent will consist of attributes name and roll number both. And second relation student with attribute name, that is student name and roll number, where roll number is its primary key. Both the relations are related to each other through the attribute roll number, acting as a primary key in the relation student and as foreign key in the dependent relation. Third rule is mapping of binary 1-to-1 relation types. For every 1:1 relationship type R in ER schema, firstly identify the entity types that are participating in the relationship and make relation correspond to them. In our case, we say relations S and T are designed to correspond to entity types participating in the relationship R. There are two possible approaches to map relationship into relation S. The first approach is foreign key approach. In this approach, we choose any one of the relation and include the other relation's primary key as the foreign key in that relation. All the attributes of the relationship is included as simple attributes to the relation chosen. The entity type with total participation will be better to choose. By adding foreign key attribute in the relation, the relationship is maintained between two entity types. For example, consider the given ER schema and corresponding relation. Here in this relation, entity type with total participation student is chosen and the key attribute of the other entity type laptop is added and chosen as foreign key. The relationship attributes here are also included. Here the key attributes of SN hash of laptop means serial number of the laptop has been renamed as LP underscore SN, and the attribute of the relation have, that is the condition, has been converted into one of the attributes with the name HAV underscore condition. And the second approach is to merge relations. First was foreign key and now is merge relations. By merging, we mean to merge the two entity types and the relationship into a single relation. The primary key of the relation is the key attribute of either entity type. This may be appropriate when both participations are total. For example, consider the given ER schema and corresponding relation. Here in this relation, both the entity types student and laptop and their attributes are merged into a single relation with relationship have attributes also. The primary key can be chosen from any of the key attributes SID or LP underscore SN of the entity types. Next is mapping of binary one to many relationship types. For every binary one is to many relationship types are in ER schema, firstly identify the entity types that are participating from the N side of the relationship and make a relation of it. Its key attribute will become primary key of relation. Include the primary key of other relation in the relationship as the foreign key in the relation chosen from N side of the relationship. This is because each entity instance on the N side is related to at most one instance on the one side of the relationship type. Include all the attributes, whether they are simple or composite, of the relationship type as the attribute of chosen relation from N side. For example, consider an ER schema of entity types student and professor with relationship type advisor. Its relational mapping will be as follows. Here all the attributes of entity type student are included in the relation because it is from N side of the relationship. The key attribute of the entity type professor is chosen as foreign key for the relation, and all the attributes of the relationship type advisor are also included in the relation, and the primary key of the relation is the key attribute of the entity type student. Fifth rule is mapping of binary many to many relationship types. For every binary many to many relationship type R in ER schema, firstly create a new relation to represent R. Include primary key of the participating entity types as the foreign key in the relation. Their combination will become the primary key for the relation. Also include all the attributes of the relationship types, whether simple or composite, if any, to the relation as its attributes. It should be noticed that we cannot represent many to many relationship type by a single foreign key attribute in one of the participating relations because of the m:n cardinality ratio. For example, suppose we have two entity types, supplier and product, having many to many relationship. So their relational mapping will consist of three relations, two for each entity types supplier and product, and one for the relationship type named product underscore supplier. The product underscore supplier relation has primary key of relations of the relations supplier and product as foreign key. Sixth rule is mapping of multi-valued attributes. For each multi-valued attribute in ER schema, build a new relation schema with two attributes. In these two attributes, one will be for the primary keys of the entity type that has the multi-valued attribute, and another will be for the multi-value attributes. Each cell of this attribute holds only one value. So each value is represented as an unique tuple. Primary key for this relation is the union of all the attributes. If the multi-valued attribute is composite, we include its simple components. For example, suppose we have an ER schema having entity type student. This entity type has a multi-valued attribute children. So, to map this multi-valued attribute, we make a new relation having children as its one attribute and stu underscore SID as the primary key of the entity type student. The primary key of the relation will be the union of these two attributes. And the last one is mapping of n-array relationship types. For each n-array relationship types R, create a new relation to represent R. Include as many attributes in the relation as many participating entity types are there. The primary key of all the participating entity types will become its foreign key. Also, include all the attributes of the n-array relationship type, whether they are simple or composite attributes, as the attributes of the relation. The primary key of this relation is the union of all the foreign keys that are present in the relation. That is how the mapping of n-array relationship is done. For example, we have an n-array relationship here. So, in order to map it in a relation, we make a relation and include primary key of all the participating entity types as its foreign key attributes, and also the attributes of relationship types as its attributes. The primary key of this relation will be the union of all the foreign keys that are present in the relation. Hence, we are finished with mapping of an ER schema to a relational model. Here we have covered the mapping of strong entity types to weak entity types and all types of relationships like one to one, one to many, etc. mappings. So, this all shows how can we map a conceptual ER model to a database implementation to relational model. With this, we come to an end of the today's lecture. In the next lecture, we will cover the concept of SQL. Thank you.